This is the thing. So next, what we wanted to prove here, now we have proved that when A is having finite order, then this subgroup is equal to this set. Now we wanted to prove that for finite order, if we have a to the power I is equal to a to the power j, this would happen if and only if n divides I minus j. So this is what we wanted to prove here in this particular case. Correct? So let's proceed and see this thing. When the order of A is finite, so the order we have assumed here is n, and first of all we assume that a to the power I is equal to a to the power j, and we shall be proving that I is equal to j, right? So if because we have assumed a to the power I is equal to a to the power j, so it implies that a to the power I minus j is equal to e, right, according to the calculations that we made previously. Again, we can apply the division algorithm. So now we are applying the division algorithms, taking I minus j as the dividend and n, which is the order of the element A, as the divisor, right? So we with this dividend and with this divisor, we have the integers q and r such that we have I minus j is equal to qn plus r, where what is this r? This r would lie between 0 and n, and we have equality at 0, right? The remainder could also be 0. So basically we assumed this thing and we wanted to prove that I minus j is divisible by n, right? For a minus j to be divisible by n, this r should be 0, right? So let's see. We take this element a to the power I minus j. So this would be equal to a to the power this qn plus r, right? And because from this equality here we have identity is equal to a to the power I minus j, and this is equal to a to the power qn plus r. So you may write this thing as a to the power qn and a to the power r. Then you can write this a to the power qn as a to the power n raised to power q multiplied with a to the power r, right? And what is a to the power n? That is identity, right? This is the identity, and because the order of the element A is equal to n, so a to the power n is equal to identity. So e to the power q, this is e, right? And e multiplied with a to the power r is a to the power r. So that means here this tell us that this e is basically this a to the power r. So we have this thing, and the condition on r is that r is lying between 0 and n. Now remember that we considered this n as the order of the element A, right? Order of the element A. So so that we now have a to the power r as equal to e, and this r is smaller than this n. So this contradicts the definition of order, because n was the least positive integer such that you have a to the power n is equal to e. But now in this case we have even a smaller number than n such that a to the power r is equal to e, but that is not possible, right? So therefore this r should be 0 only, because if it is less than n, then this thing won't work, right? Because we have already defined n to be the order of the element A. So this should be the least positive integer of such kind. So r should not be there, so r should be 0. If r is 0, we have I minus j is equal to qn. So that means this n divides I minus j. So this proves one way of the proof. Now next we wanted to prove that if n divides I minus j, then a to the power I is equal to a to the power j. This one we wanted to prove. If n divides I minus j, then that means we can write this to be I minus j as some multiple of n. So we say q, it is q times n, right? If that is so, then we may write a to the power I minus j as equal to a to the power nq, and we may write this a to the power nq as a to the power n raised to power q. And what is a to the power n? That is e, and e to the power q is e only. So that means we obtain a to the power I minus j as equal to e. So we may solve this expression and simplify it, we may write this as a to the power I, a to the power minus j is equal to e. So we may multiply both sides with a to the power j, right? So that we have e into a to the power j. So this thing is a to the power I into e is equal to a to the power j. So we have a to the power I is equal to a to the power j. So this is the proof of this theorem. So I hope you understood this one. Well, that is it for this video. Thank you for watching.